Welcome, everyone. I'm thrilled to have you here. Today, we're diving into a critical topic for any modern enterprise: data protection and governance for Microsoft 365 and Copilot. With AI accelerating how we work, securing our data has never been more important. Let's get started. Let's kick things off with the big picture. When we talk about governance in Microsoft 365, we are primarily talking about Microsoft Purview. Think of Purview as your unified command center for data security and compliance. Why do we need this? Because the old days of simply putting a firewall around your corporate network are over. Today, data flows fluidly across remote endpoints, cloud storage, and AI assistants. Purview allows us to discover, classify, and protect data wherever it lives. We are moving away from manual, reactive audits to a proactive model that analyzes user behavior, data movement, and AI interactions in real time. This is the foundation we must build before we can safely unleash tools like Microsoft 365 Copilot. Looking at this flowchart, you can see how Purview is structured into three main pillars: data security, data governance, and risk and compliance. Under data security, we have our active shields like data loss prevention and information protection. Under governance, we map and catalog our assets. Finally, risk and compliance handles investigations with e-discovery and insider risk management. These pillars work together to provide a 360-degree defense. A major concern I hear from IT leaders is, will Copilot expose our sensitive data to the whole company? The answer is a definitive no, provided your existing permissions are correct. Copilot does not bypass your security. It operates strictly within the Microsoft 365 trust boundary. If a user cannot open a confidential HR file manually, Copilot cannot read or summarize it for them. How does this work? Through Microsoft Graph. When a user asks Copilot a question, the system uses that user's unique OAuth token to query the graph. Graph acts as a secure gateway, applying semantic indexing to find conceptually relevant files, but strictly filtering out anything the user lacks permissions for. This means Copilot security is only as good as your underlying data governance. This diagram visualizes the Copilot data flow. The user submits a prompt, which Copilot passes to Microsoft Graph along with the user's identity token. Graph checks permissions in real time. The solid line shows access granted to the user's own emails and allowed files. The dotted line shows Graph explicitly blocking access to restricted data. Finally, only the permitted data is used to generate the secure response. You simply cannot protect what you cannot see. That is why data discovery and classification is our foundational step. Before we worry about Copilot, we have to scan our environment: SharePoint, OneDrive, Exchange to find the sensitive data. We do this using Microsoft Purview Data Explorer. We look for predefined sensitive information types, like credit card numbers or social security numbers. But for maximum accuracy, we use Exact Data Match, or EDM. With EDM, you can upload a hashed, secure list of your actual customer or employee IDs. The system then scans your entire environment for those exact strings, drastically reducing false positives. Once we classify the data, we can build policies around it. Here we see the discovery engine in action. Unstructured data flows into the Purview scanner. The classification engine then routes it. Standard patterns like credit cards go through sensitive information types, while proprietary databases go through Exact Data Match. Both streams feed into the Data Explorer dashboard, giving administrators a complete, unified map of where risk lives in the organization. Once we know where our data is, we protect it using sensitivity labels. Think of a label as a persistent security wrapper. If a document is labeled highly confidential, that label stays with the file even if it's downloaded to a USB drive or emailed outside the company. We can configure these labels to enforce heavy encryption or apply visual watermarks. What's brilliant is how this interacts with Copilot. If a user asks Copilot to summarize 3 documents, and one of them is labeled highly confidential, Copilot respects that label. If Copilot generates a brand new Word document from that summary, it automatically inherits that highly confidential label and all its encryption settings. AI doesn't break our security, it carries it forward. This sequence diagram illustrates label inheritance. The user asks Copilot to summarize a file. Copilot reads the file and detects the highly confidential label. When Copilot generates the brand new summary document for the user, it doesn't just paste the text, it automatically stamps that new document with the exact same highly confidential label and its associated encryption. Security is maintained seamlessly. Data loss prevention, or DLP, is our active enforcement layer. While labels protect the file itself, DLP monitors how data moves. If an employee tries to email a spreadsheet full of social security numbers to their personal Gmail, DLP steps in. It can block the action entirely, or it can warn the user and require a business justification. Crucially, with Defender for Endpoint, this extends to the physical device, blocking users from copying sensitive data to a USB drive or pasting it into an unauthorized web browser. And yes, DLP governs Copilot too. If a user tries to force Copilot to extract data that violates a DLP policy, Purview will intervene, block the AI from revealing the data, and log the attempt for security review. This diagram shows the DLP policy engine evaluating user actions in real time. Whether a user tries to email sensitive data externally, copy it to a USB drive, or use Copilot to bypass controls, the DLP engine catches it. It dynamically decides whether to block and alert the admin, enforce an endpoint restriction, block the AI output, or allow safe internal sharing to proceed normally. Generative AI introduces a massive paradigm shift. It creates data as fast as it consumes it. This brings us to Data Security Posture Management, or DSPM for AI. DSPM gives us X-ray vision into how AI tools, including Copilot, are interacting with our sensitive data. It tracks what users are asking Copilot, what Copilot is generating, and ensures that new AI-generated content is properly labeled and stored. Furthermore, DSPM is vital for catching shadow AI employees using unsanctioned, third-party AI browser extensions or apps that try to scrape M365 data via APIs. DSPM flags this unauthorized access so admins can block it immediately, keeping our intellectual property safe. Here we see DSPM for AI sitting at the center of our AI data flow. It monitors data access from sanctioned tools like M365 Copilot, as well as unauthorized third-party shadow AI tools. It constantly analyzes prompts, responses, and API extractions. All of this telemetry is fed into the Activity Explorer dashboard, giving compliance officers a complete forensic view of AI behavior in the enterprise. Let's make this real. Imagine your organization is executing a highly confidential merger, codenamed Project Apollo. How do we secure this while letting the M&A team use Copilot? First, we create a Project Apollo sensitivity label. This encrypts the files and restricts access exclusively to the M&A group. Second, we deploy a DLP policy that strictly blocks any external sharing of Apollo-labeled documents. Now, the M&A lead asks Copilot to summarize 50 pages of due diligence. Because they have permission, Copilot complies. It generates the summary and automatically applies the Apollo sensitivity label. If that lead mistakenly tries to forward that summary to their personal email, DLP instantly blocks the transmission. Productivity is enhanced, and security is airtight. Walking through the Apollo scenario, we start with our Apollo documents, which are labeled and encrypted in a secured workspace. The user asks Copilot to generate a summary. The output inherits the strict security label. Then, a risky action occurs: an attempt to email it externally. The DLP engine steps in, detects the violation based on the label, and immediately blocks the action while alerting the security team. Finally, we cannot talk about governance without discussing the end of data's life. Keeping data forever is a massive legal and security risk. Data lifecycle management automates how long we keep data and when we destroy it. We can set policies to automatically delete casual Teams chats after 90 days, while retaining financial records for 7 years. If a lawsuit occurs, we use eDiscovery to place a legal hold on specific mailboxes or SharePoint sites, preventing data deletion. And this includes Copilot. The prompts users send, and the responses Copilot gives, are saved in hidden folders in user mailboxes. This means Copilot interactions are fully auditable, discoverable in litigation, and subject to your organization's exact retention policies. You have total control. In this final diagram, we trace the data lifecycle. Data and Copilot chat logs are created and enter active use. Our automated lifecycle policies continuously evaluate the data. If a lawsuit triggers, data is routed into eDiscovery preservation via a legal hold. Otherwise, once the defined retention period expires, the data flows directly into automatic deletion, minimizing your organization's legal liability and storage footprint.